Welcome to another episode of This Is My Architecture. Today with me, I have Grant from ACV Actions. Hi, Grant. How are you doing?
Hi, I'm well, thanks.
So, Grant, tell me a little bit of what ACV does.
Sure. So ACV is a automotive platform and marketplace, and we primarily facilitate online auctions and vehicle inspections for wholesale dealerships across the U.S.
Very nice. So, actions and deals, that sounds like a lot. Can we dive into the architecture on how you handle that?
Sure. So it's definitely a lot. We're currently serving hundreds of millions of requests per month. And the way we actually end up serving that is through our mobile clients and our web-facing clients. So what happens is every request comes through load balancers, and those end up getting spread down into all of our different microservices that are hosted on our EKS clusters.
I see. What kind of microservices? What kind of services do you have there?
Sure. So our microservices can be anything from I need to facilitate the timers in an auction, to I need to launch the actual auction, to I'm a user, I need to place a bid, to I need to send push notifications, to give me transportation quotes for transporting a vehicle across the states.
That sounds like a lot. All of those services, are they individual scaling or?
Yeah, so they're all individual. So we have about a dozen or so domain teams that run these 50 or so different microservices across all of our different production clusters or whatnot.
And all of these individuals, what is that themselves? How do you design them? Are they all the same? Do they use the same compute or?
So no two microservices are alike. So what we have in our Kubernetes clusters are multiple node groups. So whether it's a microservice that's really CPU intensive, they might be scheduled on a compute node group, and we even had node groups for things like machine learning to do GPU based instances in our Kubernetes clusters and whatnot.
Oh, interesting. And is there a specific reason why you use EKS to actually design this infrastructure?
Sure. Scale is the number one thing. So like I said earlier, we're serving hundreds of millions of requests per month right now, and we plan on serving a lot more in the future. So scale, we have dozens of teams that are producing microservices and shipping to production hundreds of times a week, and we really needed a containerized architecture to kind of meet that expectation.
Wow, that's a lot of teams working together. It also sounds like a lot of data comes here. Do you preserve that data at some point? Do you have a single source of truth?
Yep, absolutely. So each one of our domain teams is given RDS instances across our different environments and whatnot. And these RDS instances can communicate with our EKS clusters and whatnot. So they're given the freedom to kind of architect how they want their databases to line up within that instance, within that scope, and then they can use that to persist whatever data their services actually need.
Right. And you mentioned the services and they all work together. How do they communicate?
Sure. So they communicate primarily through our Kafka. So in Kubernetes, we provide sidecar containers that essentially provide communication to our Kafka clusters to a service we call Data Hub. And essentially what that is a way for all of our services to produce and consume events back and forth from Kafka clusters. So we, one service produces an event to say, hey, maybe you placed a bid, and another service consumes that event and says, I need to maybe write that bid to the database or something.
Nice. And you're using Kafka then as a message bus to communicate between all of your microservices. Then are you using Kafka for anything else?
Absolutely, yeah. So our second main use case for Data Hub is our analytics team, essentially. So like I said before, we're producing all of these events from all of our different microservices, like for something like bidding, for example. But our analytics team really needs to know this information to make business decisions in as near real time as they possibly can get. So what we've been able to produce here is a system where a microservice can produce an event to Kafka, and our analytics team can either, literally watch that live stream off Kafka and watch live events, or they can build their own consumers down here and build out projections that they can then build, reporting dashboards and whatnot to make business decisions.
I see. So you're using Kafka as a message bus and also as a reporting. What kind of analytics is your team running on them besides the live stream?
Sure. A great example is sell-through. So we launch thousands of auctions a day, and not all of them sell, and some of them need to run multiple times to sell and whatnot. And it's a really important business metric to understand what our current sell-through is at. What actually dealers are selling cars, what dealers are not selling cars, who's buying, those kind of things.
So right now, Grant, you're using Kafka for messaging, monitoring, and analytics. It's very nice. I love your architecture. Thank you for sharing this with us.
Thank you.
And thank you for watching This Is My Architecture.